All right, hello Calculus BC. You're looking at this title and saying we just did some pre-calculus review, and you did, but not within your book. All right, and this involves two more items that are very, very small. And they're important because you will be using these items, not only the next section, but for one of them throughout the entire first quarter. Okay, it deals with secants and tangents to a curve. So give me a moment here. I'm going to draw a graph. And I'll make a function up. And here's what I'm going to do. I am going to draw something that is recognized as tangent to a curve. Now, you may remember this back in geometry. Tangent means that your curve is intersected by a line at only one location. So let me see if I can make that look good. That's probably not too bad. And you can see that this line is unique to this point because it only intersects at one spot, and that's where you see it right there. Okay. Every point on the curve has its own unique tangent line. And if I were to draw another one, it may look like should have quit while I was ahead. Something like that. Okay, maybe it intersects just right there. Okay, you're like, Rothery, that doesn't look like it intersects, so I will make my point bigger so it looks like it does. All right. Okay. Conversely, we have something called a secant line. And a secant line means that it intersects in more than one spot. Okay, so you can see that this secant line intersects my function, which I will call f of x, in two locations. So this is a secant, and these are both tangent lines. Cool? All right, so keep that in mind as you're working through the intense 4 problems that you're given in this book assignment. Okay, so to make things even harder, we have the distance formula from back in Algebra 1. Okay, so just to remind you what this is, sometimes calculus students say, are you going to give this formula on the test? The answer is no, you should know this. x2 minus x1 squared, y2 minus y1 squared. Add those together and square root it. That's the distance between any 2 points on a coordinate graph. So here's what I got. I got 2 coordinates. I went off my PowerPoint. What's a file? Okay, I'm going to mark off 1, -2, and -3, 4. Okay, and then here's what I'm going to do. I'm going to count over. Not sure, I'll count down first. Vertically, how much do I have to go down so that I'm finally even with my other coordinate? And so if you look, it looks like there's about 4 here and another 2 here that looks like about 6. And if I go horizontally, this looks like about a distance of 4. And what that will do is that will give me an overall distance of some number by using Pythagorean theorem. Okay, so off to the side, I have 6 squared plus 4 squared, all square rooted. That is my distance. And so this gives me 36 plus 16, which is the square root of 52. And I'm just going to stop right there. No big deal. Now, if I were to do this longhand by using this kind of big formula here relating to the distance, it would look something like this. Okay, and I know you know what this work looks like. Again, these are your x's. So I'm going to call this, let's see, we'll call this x2 and y2, and this is x1 and y1. And if you were to input those values into our distance formula, you would get something that looks like this. And notice that this is very similar to what I had right there. Okay, now some will say, why is it negative here? Well, first, it won't matter because we know we're squaring to make things positive. But second, it just depends on how you count. If you count from top to bottom, okay, it's looked upon as one direction, or if you go from low to high, that is another. It just depends. But in the end, it's the length that's most important, okay? And so at the end, we get the same thing, the square root of 52. I need you to keep these two items in mind, your distance formula, okay, and the previous screen, which was on tangents and secants, in your head as you're working through these 4 problems, okay? If you have any questions on it, you let me know, and we'll get you straight, all right? Hope you're doing well. We will see ya on our Google Classroom or something like that, all right? Goodbye.